Welcome to my video for the 2019 Key Stage 2 Maths SATs Paper 1 Arithmetic Paper. What I suggest you do for this video is to download the paper. The link will be in the description. Give yourself 30 minutes. Be very strict on that. Don't go above that. Try and complete as many questions as you can as if it was a real test. And then what you should do is come back to the video once you've finished and see if you got the marks. Okay, so the first few questions are all about speed and efficiency. So we want to get through these questions as quickly as possible while obviously making sure we get the answers right. So what I suggest we do is sort of minimal working out. Sometimes you do have to put some writing on the paper. Other times you can just do it in your head, which is absolutely fine. But as you can see, these are only worth 1 mark. So the less time we spend on them, the better. Number 1 then, 6,000 plus 90. You should be able to do that in your head. The answer is 6,090. Make sure that you've got your place value correct. Otherwise, obviously, you're going to get that one wrong. Number 2, that's a little bit more complicated. I'm going to just make a couple of notes, make sure I get it correct. 8,275 plus 82. We start with the units. 5 add 2 is 7. 7 add 8 is 15. You put the 5, carry the 1. 2 plus 1, add nothing there, is 3. 8 add nothing is 8. So our answer is 8,357. Finally, question 3 is actually a partitioning question. So 826 is the same as 800s, which we know, something tens, as I can see, and 6 units. So it would be 800, 2 tens, which is 20, and 6. So that's just basic partitioning. You shouldn't need to do any calculation for that. Number 4, something plus 5 equals 341. So what you need to do there is go backwards, do the inverse. So instead of adding 5, we're going to subtract 5 from this answer, and that should give us what's in this box. So 341, take away 5, count back, is 336. Question 5, 9 times 41. You could do this in a number of ways. The way I'm going to do it is 9 times 4, 9 times 40, you know that, and then 9 times 1 is 9, and I'm going to add them together. So 360, add 9 is 369. Number 6, again, we may need to do a bit of writing for this one. So 5.87 plus, make sure you line everything up correctly, make that look a bit nicer, 3.123. Now, as you can see, there's a gap there, so there's nothing in there at all. So what we need to do there, just so we don't get confused, is substitute it with a 0. Because there's nothing there, we can say, obviously 0 is worth nothing, so we can put that in instead. 0 add 3 is 3. 7 add 2 is 9. 8 add 1 is 9. And 5 add 3 is 8. So the answer is 8.993. Okay, the next few questions are pretty much entirely based on your knowledge of times tables, which is why it's so important that you do have a good knowledge of those and you practice those all the time. 180 divided by 3. Now, obviously, you could count up in 3s. You could do it as a bus stop method, but that would take a long time. So instead, what we'll do is imagine that 0 is not there. How many 3s go into 18? Well, if you know your 3 times table, you know the answer is 6. But because it's not 18, it's 180, it's 10 times greater. Our answer is also going to be 10 times greater, so it should be 60. Number 8, 120 divided by 12. This is just times tables. How many 12s go into 120? Well, you should know that 10 12s are 120. Number 9, 213 times by 0. Anything times by 0 is always 0. There's always a question like this in the SAT. You should just know that. Shouldn't need to be any working out there at all. Number 10, again, it's another times table based question. How many 7s go into 91? Well, there are a couple of ways you can do this. You could partition it. You could do a bus stop method if you desperately wanted to. But again, the quickest way is probably to just use our knowledge of times tables. How far can we go with a 7? So 7 times 12, I know, is 84. So I'm just going to make a note of that there. 84 is 12 7. If I add another 7 onto 84, we're going to end up with 13 7s. So 7 onto 84, if I add that, it should make 91, which it does. So that suggests to me, if this was 12 7s, and we add another 7 to make 91, then the answer should be 13 7s. Number 11 is just a normal subtraction, but because they've moved it the other way around, normally the sum starts here and it equals something and the answer goes there. Because they've done that, some people get a bit confused and get caught out. So just switch it around if you have to, but it really doesn't make a difference. 87 minus 65, 7 minus 5 is 2, 8 minus 6 is 2, so our answer is 22. Number 12, 602 minus something equals 594. It's really just find the difference between these two numbers. I would just count back. So if we count back 2, we get to 600. If we count back another 6, we get to 594. So it's the initial 2 we counted back, and then another 6. So 2 and 6 make 8. 602 minus 8. Always read it off and make sure it makes sense. 602 minus 8. Yes, it does equal 594, so that's correct. 13, 1,210 divided by 11. At first, this looks fairly complicated, but if we were to imagine the zero is not there, it's really just 121 divided by 11, which, if you know your times tables again, should be absolutely fine. 11 11s make 121, so our answer would be 11 if it was 121. But because it's 10 times greater, there's a 0 underneath there. Our answer also needs to be 10 times greater, so the answer is 110. Okay, number 14, 25.34 times by 10. If we times something by 10, the entire number here is going to jump to the left. It's just simple place value. So you don't have to do any calculation. All we really need to do is slide these numbers along. So initially, this is in the tens column. This is in the units, the tenths and the hundredths here. So if we were to move this entire number across here, this 2 that's in the 20, it's in the tens column, would actually now be in the hundreds column. So it would be 200. The 5 would also move into the tens column. So that would be 50, 250. The 3 is moving from the tenths to the units. So that's 253. We've still got to have a decimal point there. And there are 4 and now in the tenths column. So it's 253.4. Number 15 is an example of BODMAS. If you have struggled with this one, I have a video of BODMAS on my YouTube channel, so have a look at that and see if you can improve on that, because it's very important. The first thing we do with BODMAS is we start with brackets. I won't go through the whole BODMAS theory here, so if you do need to know that, obviously go and have a look at that video. We do the brackets first. 30 minus 24. So 30 minus 24 is 6. Then the next thing we need to do is do the division. So 60 divided by our answer, which was 6, is going to be 10. Number 16 is 3 to the power of 3, or 3 cubed. And all that literally means is 3 times by 3 times by 3. So we can do that in chunks. 3 times 3 is 9, times that answer by 3. 9 times 3 is 27. Number 17, 101 times by 1,000. Again, if we're times it by 10, 100 or 1,000, the whole number is going to shift to the left depending on how many zeros there are. But because there's 3 zeros, all of our numbers are going to jump 3 spaces. So our answer, once it's complete, would be 101 with those 3 zeros on the end because it's moved 3 spaces along. So it would be 101,000. Number 18, 20% of 3,000. So what I would do in my head is do 10% of 3,000, so divide it by 10, which is 300. So obviously 10% is 300. We need to have twice as much to make it 20%. So 300 times 2 equals 600. So that is our answer, 600. Number 19, 7 minus 2.25. So there are a number of ways of doing this. You should know that there are 100 hundredths in 1 unit. So 7.00 is the same as 7. If we're going to subtract number from it, minus 2.25, obviously we haven't got anything that we can take away here. You shouldn't really need to do any complicated working out. You should just know that in order to make up the next whole, we're going to need another 0.75 to make that happen. So our answer is going to end up with 0.75. So first let's subtract the 2. So we have 5. And then we also need to subtract another 0.25. So our answer is going to be 4.75. 0.75. And if you're not sure about that, if you think, I'm not sure if that's correct, a good thing to do is to do the inverse very quickly if you have time and to go backwards. So your answer plus 2.25 should make 7. So let's have a look at that now. 4.75 plus 2.25 should equal 7. Right, 5 add 5 is going to be 10. Put the 0, carry the 1. 7 add 2 is 9. Add another 1 is 10. Put the 0, carry the 1. 4 add 2, add 1 is 7. So our answer is definitely correct. 4.75. Likewise, if we're dividing by 100, instead of moving the number to the left, we are going to move it to the right. 2 spaces to the right because there are 2 zeros. So at the moment we have 0.9. If we're going to move this 9, it's in the tenths column. 2 spaces to the right, that would be the hundredths and then the thousandths. So we're going to keep moving that along. Right, the 9 is there. Because there's nothing in this space, it's a naught. Our answer is 0.009. Number 21, 9 minus 1.9. You could do that in column subtraction if you wanted to. What I would do is say, well, 1.9 is nearly 2, so 9 minus 2 is 7. However, we aren't taking away 2, we're taking 1.9. So we've actually got to add that 0.1 back on. So it would be 9 minus 2, which is 7, plus the 0.1 is 7.1. Just like the example that we had before, if you want to check that, you can do the inverse. 7.1 add 1.9 makes 9. Number 22. Now, what we've got here is a mixed number. We have 1 whole and 3 sevenths. And what we have here is just a normal fraction, 4 sevenths. Now, before we can do anything to this sum here, we need to make sure that we have the same format here as we do here. Now, because this is a mixed number, what we're going to have to do is turn it into something called an improper fraction. And what that means is we basically move this whole number and convert it to a fraction. Well, we know that 1 is the same as 7 sevenths. Okay, 7 sevenths, it can be substituted here. We also have 3 sevenths. So 7 sevenths add 3 sevenths, making this whole bit here 10 sevenths. Okay. Now what we need to do is 10 sevenths, which is this component here, minus 4 sevenths. So 10 sevenths minus 4 sevenths is 6 sevenths. Okay, number 23, we're getting on to some 2-mark questions now, so you need to show you're working out and show that you can do this method properly. We start with the units. 7 times 6 is 42. We put the 2, carry the 4. 7 times 3 is 21. Add the 4 is 25. Carry the 2. 7 times 8 is 56. Add the 2 is 58. The next thing we need to do, because we're in the tens column, is put our 0 down. We can also cross these out so we don't get confused. 2 times 6 is 12. Put the 2, carry the 1. 2 times 3 is 6. Add 1 is 7. 2 times 8 is 16. Nothing to carry. Put that down. Our final step now is to add these numbers together. 2 add 0 is 2. 5 add 2 is 7. 8 add 7 is 15. We put the 5, carry the 1. 5 add 6 is 11. Add the 1 is 12. Put the 2, carry the 1. And then 1 add 1 is 2. So our answer is 22,572. Okay, number 24. What we've got to do here is, because they've got different denominators, that's the bottom number here, we actually have to convert these so that they have the same denominator. Otherwise, we can't add them. It's very important that if we're going to add or subtract fractions, they need to have the same denominator for us to do that. So at the moment, we have 1/5 and 3/4. What we could do is try and turn fifths into quarters or try and turn quarters into fifths, but that is quite a complicated situation. Knowing your times table, you could say, well, what's in the 5 times table that's also in the 4 times table? Well, a quick way of doing that is to just do 5 times 4. So we know that 20, that's 5 times 4, is in the 5 times table and the 4 times table. So if we can convert these fractions to be 20ths, then we know that we can add them together. So in order to turn fifths into 20ths, we need to times the top and the bottom, that's very important, by 4. So 1/5 times by 4 is 4 20ths. You have to do the top and the bottom, otherwise your answer will be wrong. In terms of the quarters, what do we do to turn quarters into 20ths? We need to times that by 5. So we times the top and the bottom by 5. 3 times 5 is 15. 4 times 5 is 20. And it's an addition. So now we can add them together. So 4 add 15 is 19 20ths. That's your answer. Number 25, we have got some short division here. So what we're going to need to do is follow the method in order if we're going to get those 2 marks. What I suggest you do, if you get questions like this, is to start by writing down the numbers, the times tables, if you will, this number down here. So obviously, we don't know our 37 times table. So what we'll do is we'll do 37, and then we'll add another 37 to it. So 37 add 37, just off the top of my head, 7 and 7 is 14, so it's going to have 4. 30 and 30 is 60, add the 1 is 74. Now we'll go one more time, because I don't necessarily think we're going to need much more than this, but we can always add to it if we need to. So 74 add 37 is 111. Right, what we do now then is we say how many 37s go into 8? Well, obviously they don't fit. How many 37s then go into 88? So how many 37s go into 88? You can see, because we've done the calculation, that only 2 will fit. If we go to the next lot of 37, that's going to be too big. So 2 lots of 37 fit into 88. Now we need the difference between 74 and 88, because that's how many spaces we've got, and that's how many we've filled. So what we've got left is 14. So what we need to do is carry the 14 to the next number. So how many 37s go into 148? Right, we're going to have to try one more time. Add 37 onto 111, we get 100, and funnily enough, we get 148. So how many 37s fit into 148? The answer is 1, 2, 3, 4. So in total, 24 37s go into 888. Okay, just like the example we had before, 26 is a question where we need to make sure that all the denominators are the same. Now we have a mixed number here and a mixed number here. The only problem is they don't have the same denominator. So what we're going to need to do is convert them. First of all, let's put them into improper fractions because they're a lot nicer to work with. So how many fifths go into 1? The answer is 5 fifths. 5 fifths add 1 fifth makes 6 fifths. So that's what this is worth in fifths. Now, this next number, we're going to convert to an improper fraction as well. So how many tenths go into 2 wholes? Well, we know that 10 tenths make 1 whole, so 20 tenths must make 2 wholes. 20 tenths plus 1 tenth is 21 tenths. Now, the problem is, still, we don't have the same denominator. These are a lot easier to work with, but because we haven't got the same denominator, we can't add them yet. Now, we could do, like we did in the previous example, turn the answer into 50ths, because we know that 50 is in the 5 and the 10 times table. But in this case, it's a lot quicker to turn the fifths into tenths. We can just double the top and the bottom here so that we've got tenths on both sides, and that will be a lot quicker. So let's times 6 by 2, which is 12. 5 times 2 is 10. So we've got 12 tenths. That's an equivalent fraction of 6 fifths. Plus 21 tenths. If we add them all together, we have 33 tenths. Number 27, find 35% of 320. What I tend to do with these is to find 10%. And it starts to build a little bit of a bank of numbers here. So 10% of 320, we just divide that by 10. And the answer for that is 32. 5% then would be half of 32. So half of 32, I know, is 16. It's really good if you can show this as well, so that if you do make a mistake, at least you've got some chance sometimes of getting the additional mark. But this is only 1 mark, so you don't need to worry about that this time. So 5% is 16. Do we need anything else? I don't think we do. I think we can make 35 with these components. If we do 10% times by 3, we'll get 30%. So 32 times by 3 is 96. So that's the answer for 30% of 320. All we need to do now is add our 5% onto our answer. So 96 add 16. 96 add 16 equals 112. Okay, number 28 is broadly the same as a question we had a couple of questions ago. We've got to make sure that our denominators are the same again. So in this case, the 4 doesn't go into 9. We can't double 4 or anything like that. We have to think what's in the 4 times table, which is also in the 9 times table. And a quick way of doing that, like I mentioned, is 4 times 9. That's 36. So let's turn them into 36. How do I turn 9 into 36? Well, I need to times 9 by 4 to make 36. So I need to do the same to the top. 8 times 4 is 32. And obviously the bottom will be 36. How do I turn quarters into 36? I times the whole thing by 9. So minus 1 times 9 is 9. 4 times 9 is 36. That's our sum that we can solve now. 32, 36 minus 9, 36. 32, 36 minus 9, 36 is 23, 36. Number 29 is quite straightforward. All we've got to do is find 50% and 1% and then add them together. So what's 50% of 900? Well, you should know that 50% is half. So half of 900 is 450. 1%, well, if we want to find 1% of anything, we just divide it by 100. So 900 divided by 100 is 9. I'll just put that equals 1% there so I don't forget. We've got 50% here, 450, and 1% here, which is 9. We just need to add them together. 50% and 1% obviously makes 51%. 450 add 9 is 459. Okay, we've got another long multiplication question. 2 times 8 is 16. Put the 6, carry the 1. 2 times 6 is 12. Add the 1 is 13. Carry the 1. 2 times 4 is 8. Add 1 is 9. 2 times 3 is 6. Now remember, when we move on to tens, we have to put our placeholder 0. 6 times 8 is 48. Put the 8, carry the 4. I should have crossed out these ones. Always important you do that, because otherwise you can get confused. 6 times 8 is 48. Carry the 4. 6 times 6 is 36. Add the 4 is 40. Put the 0. Carry the 4. 6 times 4 is 24. Add the 4. 28. Excuse me. Carry the 2. 6 times 3 is 18. Add the 2 is 20. So we just need to add these answers together. 6 add nothing is 6. 3 add 8 is 11. Carry the 1. 9 add 1 add nothing is 10. Put the 0, carry the 1. 6 add 8 is 14. Add 1 is 15. Put the 5, carry the 1. 1 add nothing is 1. And 2 add nothing is 2. So our answer is 215,016. Okay, we're getting into the harder questions now, the final few questions of the paper. 2/3 divided by 3. Now, all you need to remember here is if you divide a number, it's going to get smaller. So that means our denominator is going to get bigger, because obviously the bigger the denominator, the smaller the chunk is of the whole number. So in this case, 2/3 divided by 3, all you need to remember is if you're dividing by the whole number, is to actually multiply the denominator, and that is it. So 2/3 divided by 3 will be 2 over 3 times 3, which is 9. So our answer is only 2/9. And that's the same anytime you have a fraction divided by a whole number, you just times the denominator by the whole number, and that's your answer. 32, we've got another fraction related question. So what we need to do, as we've done before, is convert this into an improper fraction. So what we need to do is say how many halves go into 2 wholes. Well, that's 4 halves, plus another half is 5 halves. Okay, minus 3/4. Now, this one's a little bit easier because we can turn half into quarters quite easily. All we need to do is multiply the top and the bottom by 2 so that we end up with 4 as a denominator. So that would be 10 quarters minus 3/4, which we can now do. 10 minus 3 is 7, so 7/4 is the answer. Number 33, find 36% of 450. So just like in the last example, I said find 10%. So find 10% of 450, divide it by 10, is 45. What we can do is also find 5%. So let's have a look at that. Well, in this case, it's going to be a decimal, isn't it? So 45 divided by 2 would actually be 22.5. So I don't like that. I think what I'm going to do instead is I'm going to find 2%. So finding 2%, all we need to do is divide this by 5. Well, how many 5s go into 45? It's 9. So 2% is 9. Now we can actually build 36% with 10% and 2%. All we need to do is 10% times 3. So 45 times by 3. Let's do a bit of written method so we don't get it wrong. 3 times 5 is 15. Carry the 1. 3 times 4 is 12. Add another 1. So 135. So 135 is 30%. I just make a note so I don't forget. 30%. Now we need 36%. So if we want to times this by 3, we'll get 6%, because obviously 2 times 3 is 6. So 9 times 3 is 27. So 27 is 6%. Now we've got 135 is 30% and 27 is 6%. So if we add these together, we're going to end up with 36%. 135 add 27 off the top of my head is 162. So that's our answer. Okay, number 34. First thing we need to do, as we have done several times on this paper, is turn it into an improper fraction. So how many quarters go into one whole? The answer is 4. So it's 4/4 plus 3/4, which is 7/4. Now, 7/4 times by 10 is super easy. All we do is times the numerator by our number. So 7 times 10 is 70/4. Now, you could simplify it if you want to. So that means turn it back into its lowest possible form. I think we're going to leave it because it's only worth 1 mark, and I'm sure in the mark scheme that will be correct. Okay, final 2 questions now. So we're going to really make sure we get these right, because these, in theory, should be the hardest ones on paper. Right, find 5/6 of 540. Notice it says 5/6 times by 540. That's exactly the same as find 5/6 of 540. If you struggled with the fractions of the math, I have a video on YouTube for fractions of the math, so have a look at that and see if that can help you. First thing we need to do is find 1/6 of 540. So how many 6s go into 540? If you know your 6 times tables, it's really important. You'll know that 9 6s make 54, so 90 6s must make 540. So 1/6 is 90. Now, to finish this off, we need to multiply our answer by 5, because that's 1/6. We want 5/6, so we need to times this by 5. 90 times 5 is 450. That's your answer. Okay, number 36. What we need to do for these sort of questions is to put our multiples down, because we don't know our 83 times table. So we start with 83, and then we keep adding 83 until we get to a suitable number. Now, it looks to me like we're going to need quite a big one for this one, just from previous experience with these questions. So let's start and get to about 800 for now, that sort of number. And then if we need any more, we can keep adding more. So 83 add 83 is 166. If, for whatever reason, you can't do this in your head, it's absolutely fine to use the paper, anywhere on the paper, as long as it's not the answer box, to work it out. 83 add 83. If you need to do a written method or something like that, I would rather you do that and get the answer right than guess, because if you do guess and you get it wrong, your entire answer is going to be wrong just because you didn't add the numbers correctly. So if you need to do that, do that. 83 add 83 is 166. Add another 83 is 249. I'm going to keep going. 332. 415. 498. 581, I believe. 664. Nearly at the 800 mark. 747. And finally, I think we'll leave it there, 830. So, how many 83s go into 8? They don't. 0. How many 83s go into 80? Again, it doesn't fit, so it's 0. How many 83s then go into 805? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. We haven't got enough to do 10 because that would be 830. So 9 83s fit. Now we need to look at the difference. So we have 747, so that's 9 83s, and we need to look at the difference between 747 and 805. So what we need to do here is 805 minus 747, which we can do this way. 5 minus 7 we can't do, so we're going to need to borrow one. We haven't got anything to borrow here. This one does. 10. Now we can borrow one from it. That's now 9. That's 15. So 15 minus 7 is 8. 9 minus 4 is 5. 7 minus 7 is 0. So the difference is 58. Right, now if we put 58 back in, squash it in there, how many 83s go into 581? 1, 2, 3, 4, 5, 6, 7. The answer is 7. It fits perfectly. Our answer, therefore, is 97. I hope you found that video helpful. If you did, please give it a thumbs up and a like and subscribe. That would be really helpful for this channel. If you did really well, then congratulations to you. If you found that quite challenging, what I would recommend you do is go back to the YouTube channel, Mr. Wall, and have a look at the free videos and use them to revise and practice so that when your SATs do come around, you'll be in a better position and you'll do even better. Thanks for watching. See you next time.